This time last year, we were on the same stage competing for the Student Design Challenge. And it's an honor to be back this time as the past winners, presenting our project and showing you what we've done so far, and also talking about what the next steps look like. Once again, thank you for the opportunity to be a part of this event and to present here again. Yeah, we're Team Sally from BITS Goa. So yeah, let's dive a little bit into our story and where we started. The problem statement for the Student Design Challenge, which is essentially where Akansha and I first came into the accessibility space itself, was this question about how does a blind person or a blind student measure out exact volumes of liquid? So when we initially saw the problem statement, like we naively assumed that we could just build tech and just solve the problem. But the reality check happened when we actually visited a bunch of blind schools, saw that there is no infrastructure to enable STEM education, especially in terms of lab infrastructure. And so we realized that complex tech could possibly not be able to solve this challenge. That's when we started from the basics, try to envision what it would look like for a blind student to be able to carry out an experiment. So they first have to identify a particular chemical and then pick it up and be able to pour it out and measure. So the first step is identification, and so we went ahead with trying to use braille labels to enable navigation. And why braille labels? Because been around for a while, and at least the schools that we went to, students were very familiar with braille, use that in their daily life. So we sort of decided to do that. Uh, then the next part about actual measurement, right? So this is where we developed the prototype. This first prototype. This is and we call our device Sally, for short for science accessibility. Uh, so here we used an ultrasonic sensor to be able to measure the depth and then look at the measurements of the beaker or the container, and then sort of calculate the volume. That's how we worked the last time. And we presented this at Empower 2022, got a lot of feedback from the judges, from experts in the space. And yeah, and I think these two things were key learnings from Empower 2022 and something that's guiding us as we go on building. First is user-centric design. So who's at the center of what we are building? So this is being built for the blind students. So the blind students and their educators have to be an important part of this process. So that's something we keep in mind from day one. Like we always keep going back to the students and getting their feedback at every single stage and trying to incorporate that. And the second thing is the idea of universal design. So to be able to take these technologies mainstream, what we have understood is that that sighted people should benefit or at least find some value out of what we're doing as much as visually impaired students are. And yeah, so with this sort of ethos in mind, this is a snippet from a user.
तो हम लोग रेडी होने से उससे पहले ही सामान चाहिए। अच्छा मतलब अभी हाँ अभी हमें ये करना है इससे पहले।
हाँ, मतलब ये शुरू हो रहा है ऐसा।
शुरू होने से पहले हिंट मतलब जैसे कि हाँ स्टार्ट करना है। उसके बाद वो वॉइस करना। ठीक है।
हाँ वो हमने सोचा नहीं।
हिंट डाल जैसे कि हम लोग कोई गूगल पे सर्च करते तो वो माइक होता है वो 10 सेकंड के लिए कुछ ओपन होता है तो उसी के बीच में बोलना होता है ना। तो उससे हमें पता चलता है कि हम हाँ ये बोलना है ये बजने वाले साउंड और करना मतलब सर्चिंग फिनिश होने के बाद वहाँ पर और एक साउंड आता है तो ऐसा हो मतलब हमारा एक हो गया।
ठीक है, मतलब शुरू होने पे आपको कितना डालना है ऐसा पूछना चाहिए और फिर आप बोलेंगे कि ठीक है 5 ml 10 ml ऐसा आप बोलेंगे। फिर उसके बाद हाँ एक साउंड आना चाहिए कि हाँ आपने जो डाला है ये कंफर्म हुआ है।
साउंड होने के बाद वो कंफर्मेशन बताना चाहिए।
So, I mean, except for the terrible Hindi, I think this is really good feedback. This is a good feedback session from the students. So they're actually telling us that we need to be incorporating voice to. So the voice like the voice input output option wasn't there in the initial prototype that we had, and the students are telling us that we need this to be enabled by voice. So this is one of the key feedback that we got for our initial prototype, and then it also leads us to this question of what set of experiments can we make accessible through our device, and for that we started working on analyzing experiments from the NCRT. Partha will.
Right. I think thanks, Anaga. So as Anaga mentioned, our whole journey was guided by the user-centric design principles. So I vividly remember last year sitting there listening to Professor Bala's talk, where we put in a lot of engineering effort to create marvels, which maybe not even is needed for the user, right? So from the beginning of our process, we were quite sure that we will follow the develop, get the feedback, refine, and keep iterating this process forever, right? So there's always scope for improvement. So as a first step, we wanted to do analysis of NCRT experiments to understand the various accessibility barriers. And this study included all the experiments and activities prescribed by NCRT for grade 6 to 10th. And we found that a massive 98.9% of experiments were inaccessible, and that is the current state. And in this study, we did not include compound disabilities or cognitive disabilities because they are not in the area of our expertise. So further, we wanted to probe about what are these inaccessible experiments. And to do that, we scrutinized all the experiments and activities and clustered them into various categories. The ones which have visual impairment as the barriers, and the ones where auditory or motor disabilities are the barriers. And we found that around 81.9% of these inaccessible experiments have a barrier associated with visual impairment, and about 17.2% with auditory and motor disabilities. So based on these data points, we were guided by a decision that we should maybe tackle the bigger problems first, that is maybe make experiments and activities accessible to visually impaired students. And maybe we also had discussed a lot about the active role of NGOs in assistive tech yesterday in the fire chat. So at this point, we realized that if we have to proceed ahead with effective user-driven product development, we might have to collaborate with NGOs across the country. And that is when we got in touch with Vision Empower, an NGO based out of Bangalore, and who are driving towards making STEM education accessible to students with visual impairments. So earlier this year, we got started where we got a grant from Vision Empower to continue our work. And the very first step was to have a very close collaboration, which is maybe as good as, say, bi-weekly meetings, to co-innovate or first explore the problem space. So we all from the tech space wanted to create something fancy, but we understood that that is not the way forward. So we had bi-weekly meetings to understand the perspectives from the special educators on how exactly science is being theoretically taught, and how do we make these labs accessible, and what is the tech that is needed. And maybe once we come up with a prototype or maybe a concept, maybe validating them with the educators and the students again. So this whole develop, get feedback, and refine cycles kept repeating. And this also gave us an opportunity to get the whole axis of network of schools that Vision Empower has, and along with their special educators. And we will touch upon those further in the next steps. So a couple of achievements from the last time we met to now. So firstly, after Empower 2022, at the end of year, we were awarded the prestigious Professor Suresh Ramaswamy Memorial Award at our institute at BITS Pilani, which also gives us full access to high-tech infrastructure for free for use, maybe like printers, 3D printers, and high-end sensors, and so on. And we also emerged as the finalists among 80-plus teams in Abu Dhabi, so which is a social entrepreneurship event at IIT Bombay last year. And earlier this year, maybe beginning of year, we also got the Clinton Global Fellowship Award, which is more of a societal and student-driven entrepreneurship mentorship program, where across the year we get mentorship from experts in STEM on how do we make affordable assistive tech for the Indian context and so on.
So, adding on to the list of achievements that Partha mentioned, we were also invited to a podcast called Ace with Passion uh, uh, by its host, where she extensively talks about inclusivity in different spheres. You can scan the QR to access the episode on Spotify. So, along with collaboration with NGOs, we realized it was also like the problem was so big that it was a Herculean task for just the four of us. So, we decided to expand our team, and now we are almost double the size of what we were with students from diverse backgrounds like chemistry, bio, engineering. We have our own in house industry expert, and we are still expanding under the guidance of Dr. Swaroop Joshi. So this is a glimpse into what Sally is right now.
Good evening. I am your assistant, Sally. What should I call you?
Akanksha.
Welcome, Akanksha. How can I help you?
So we brought this enhanced version of Sally that could detect color and could listen to you and talk back to you to empower this year. And the image that you see on the left is what we envision our final prototype to look like. So, what do the next steps look like for us? Right now, the tech that we have, which is color, volume, and the voice assistant, it's all different pieces of tech. The first step for us is to integrate all of it into one device. Then we plan on making custom lab kits, which incorporate Sally into the experiments and keeping in line with the universal design principle, we want to make these kits such that these can be utilized by students with and without visual impairment. We then plan to convert this into an industry ready prototype and again go back to the feedback loop with our users. And by next Empower, this is a pretty big goal, but we plan to beta test it with at least 10 schools until like by the time next Empower comes along. And none of this could have been possible for us without the many people from various steps in life that we met along the way and their insights. And we would love to continue this journey and we would love to hear your inputs and your insights. So if you would like to collaborate with us, this is how you can reach us, or you can catch us at our booth E41 outside. Thank you. We are really grateful for the opportunity today that we got today. And thank you so much.